Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. There we go. Shake off the cobwebs, or you know what? Put them up in the corner. They're always good decoration. Ladies and gentlemen, welcome into the program. Just before Halloween, I hope all of you have a very, very special Halloween. I think I read an article the other day that said something like it's going to exceed, is it like $12 billion or $2 billion spending? People love Halloween. I don't know what it is. I guess things have just been so crazy and out of control in, so many aspects of the news and so on and so forth. People just want something fun. And to everyone else out there that is already putting up their Christmas trees, shame on you. Halloween deserves better. So everyone, I hope that you're having a good one out there. ComputerAmerica.com. I really want to just say that in the outset, because that's where you'll find everything, including past shows, future shows, show notes, articles, reviews, topics, everything that we do. Ladies and gentlemen, coming up soon, we have CES 2024. Yeah, that's the year. CES 2024. We will be covering it remotely. Going out there is still kind of a risky proposition, but still a lot of good big announcements will be coming out of that. And if you ever want to see what's coming to you soon, CES is a great way to kind of highlight that. What's new in televisions, what's new in audio, what's new even really in cars, tractors if you're a farmer, what's new in personal robotics, home toys. Like, it doesn't matter. They have all they have all kinds of things at CES. So stay tuned for CES coverage that will be coming to you in early January. Now, with that being said, let's go ahead and bring Ralph on. He is our science and technology trends correspondent, and Ralph Bond puts together a wonderful show every single Friday to tell you all about, some very interesting, not just research, but sometimes real-world applications, space science. Hey, look, he has his own spiel. We'll let him do it. And ladies and gentlemen, welcome back onto the program. Ralph, how you been?
I'm doing great, and I'll tell you, doing well, all things considered, with what's going on in the world. This week's been horrifying with Middle East and a mass shooting in Maine, and I've been to Maine several times, and what a lovely place and how tragic. But folks, if you've come to the right place, if you want to get some uplifting, inspiring, and good news, for the most part, okay? That's what Ben and I do on Friday with the Science and Technology Trends Review. What I do is I go out and I look for articles that catch my eye. I distill them into little show notes. I come out to the show notes, by the way. Go to computeramerica.com and get the show notes, because what we do is we put in links and pictures and all that sort of stuff if you want to dive in deeper on any of the stories. I don't create any of this content. I aggregate it. I'm like a curator who finds this stuff, puts it together, and shares it with you, along with Ben, of course. And it's everything from robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, all across the board. We have a real good time with this, and I guarantee you, you'll walk away feeling better about where we're going as human beings.
Absolutely. Yep. And I think, a lot of the stories that you have are, very, very kind of future seeing. But ladies and gentlemen, I just want to say that because we have a whole playlist dedicated to Ralph. And if you ever want to check out any of our past shows, because we're going to have some, hopefully we're going to sort out, some of these in the future. But like next week, we have to unfortunately take off. Ralph's going to do something special for us over on the website. But if you ever want to experience Ralph and we happen to not be on that week, past shows are just as good, because hey, even a year ago, they're stuff that's not even out today. It's very, very kind of futuristic. So Ralph, I think with that being said, why don't we go ahead and get started with story number one?
Yes, story number one, really interesting. Two sources here. First, I saw this at Newsweek. And then I saw more details on sciencefocus.com. So those are the two sources. Again, the show notes will give you everything you need for links and so on and so forth. The headline here, irresistible. Roads can be built on the moon. Laser experiment shows. Okay, that's interesting. So here's this, and some great images here, by the way, in the show notes and from these articles. So for transport systems on the moon to be successful, solid roads and landing pads, especially landing pads, will be essential. But sending road building materials to the lunar surface, of course, out of the question, too expensive, right? I mean, it just wouldn't make any sense. The latest research comes in an era when NASA is aiming to establish a long-term presence on the moon as part of the Artemis program. We've talked about this in the past as well. While the space agencies, of course, of Russia and China are also planning to develop their own lunar base. I got to pull up a soapbox for a second here and say, wouldn't it be great if we lived in a world where all this stupid, foolish politics and
it'd be a much different world for sure.
Can you imagine if the Artemis program were an international program and that we were holding hands with the scientists in China and Russia and ourselves and Europe? Stop all this foolishness. Stop it.
I completely agree. And there's a lot of people who, are just caught up in that foolishness. But I do want to say, just kind of from the outset, though, that competition is a great innovator. True. So as much as, everyone working together doing, kind of helping each other would be great, Ralph. I got to say, it's also kind of encouraging that, instead of a competition of, who can put troops in what area, what about a competition of who can build the best moon base? Something good and productive and fun,
Yeah, I agree with that. But I also know, working in teams myself in my past career, that you can have competition within a holistic team with the same mission. So, I mean, you're right. I don't discount what you're saying. You're absolutely right. Anyway, going on, being able to construct paved roads and landing pads on the moon will be an important component of planned lunar settlements in order to mitigate issues encountered by previous missions. Now, we all know that low levels of gravity at the lunar surface can result in dust floating around when distributed by exploration vehicles. We've seen the videos, right, where it's just like plumes of dust, which can potentially damage equipment. That's why a lot of the designs for the lunar rovers and so forth have to take this into account. But what if you could have roads, right? And that's what these guys are looking at. So researchers at the Aalen University, I hope I'm pronouncing that correctly, it's Aalen University in Germany, hit a space exploration milestone when they discovered they could melt lunar soil to form a more solid, robust substance that locks in the extremely fine dust. Now, they simulated this, folks. They didn't really have a ton of real moon dust, but they simulated this. Mm-hmm. The novel approach, described in a proof of concept study published in the journal Scientific Reports, would involve melting lunar soil with focused sunlight to turn it into a more solid substance. This could be used to create paving for roads and other infrastructure like landing pads. So in experiments conducted on Earth, of course, the Aalen University team of scientists demonstrated the viability of the technique using lasers. Now, they used lasers to prove the concept, instead of the use of large lens to concentrate sunlight, which the team proposes to be used on the moon. So let's get this clear. Their experiment on Earth used lasers, but they said the lasers are kind of a stand-in for what they see in the future with people on the moon taking large lenses and concentrating sunlight, like you take a magnifying glass, right? As when you're a kid, you burn something into wood or whatever. That's what we're talking about. So again, on Earth, they use lasers to melt the lunar soil substitute simulation. Their findings indicate that the technique could be replicated on the lunar surface, although several challenges remain to be overcome. So in the study, the Aalen University team outlined how they conducted experiments that involved manufacturing tiles. So they're talking about manufacturing like modular tiles. Think of the tiles that you buy at Home Depot or Lowe's or whatever that interlock. That's kind of where they're headed. Mm-hmm. So manufacturing tiles by heating and melting the moon dust substitute. And these tiles were then allowed to cool, producing a robust, consolidated piece with an interlocking design. that measured around 25 millimeters, 1 inch in thickness. It's interesting also that they think that 1 inch in thickness would be enough to deal with vehicles on the moon's surface. But remember, the lower gravity would compensate for that, right? So it's sort of a calculation, I'm sure, based on gravity. And such tiles could be placed alongside each other to cover a wide area of lunar soil, according to the researchers. Oh, yeah. This is pretty clever stuff, Ben. I'll tell you. I bet one of them said, wait a minute, when I was a kid, I took a magnifying glass and would burn, that. What if we could do that with the moon dust? But it always amazes me how they kind of put this together in their heads.
Really, putting together some kind of settlement on the moon where, here on Earth, it's like, oh, you may have trees and water and, dirt and whatever you may have around you to build something. Ralph, I guess on the moon, you got regolith and sunlight. That's what you got. So everything has to come from that.
Yeah, and unobstructed sunlight, by the way. No atmosphere, right?
The good stuff, yes.
Anyway, yeah. So in the experiments, the scientists used high-powered carbon dioxide laser beams to heat the dust substitute, replicating the effects of concentrated sunlight that could be projected on the moon using a large lens, as we mentioned before. The spot of the beam had a maximum diameter of 100 millimeters, that's about 4 inches, and 12 kilowatts of maximum power, which has never been used before in previous studies. To reproduce this approach on the moon, the scientists proposed the use of a special type of lens measuring more than 7 feet across that would focus sunlight like a magnifying glass, just as I alluded to earlier. The lens would the lens would enable the manufacture of tiles using only sunlight and lunar soil. Talk about practical. Such a solution would be simple and low weight, a significant advantage given that transporting construction materials from Earth is costly and logistically challenging. I would say just not even viable. Forget it. But how clever, right?
Yeah, no. It's well known that the most expensive thing in space, to really send up in a rocket, is in a lot of cases water. It's so heavy, and you have to pay for it in rocket fuel. And, just such a basic thing. Like here on Earth, water and concrete mix, and there you go. You got a building material. Water, not so much. So being able to do that with a laser, super, super cool. And really, kind of the interlocking design that they, kind of put forth with the tiles, it makes a lot of sense. But my first thought, so I'm hoping other people out there have had the same first thought. I was like, I hope that the surface of the moon doesn't end up looking like Los Angeles, just roads everywhere and highways. So I decided to say, Ralph, I asked our good friend Google, how large would a structure have to be for us to see it with the naked eye here on Earth?
Oh,
so
good one.
This is not accounting for telescopes or anything like that, because you could obviously
naked eye then.
But with the naked eye, would you like to take a guess?
Oh God!
How big a structure? Let's say how big a structure across would have to be to see it here on Earth.
Maybe 100 miles by 100 miles.
Oh, you're using miles. Oh no, I have this in kilometers. 2 miles, 120. You're actually close. 75 miles. And then you could see it with the naked eye here on Earth. Which,
isn't that something? And
with the moon being like 360,000 miles away from Earth, it kind of makes sense. Yes. But still, Ralph, I guess as long as they keep the lunar base to maybe 30 miles by 30 miles, we should be fine. We shouldn't see it here on Earth, and it won't look like LA. So.
Don't ruin the romantic moon vision that you see in the sky without a telescope.
I can't but feel like that's going to be the case. Even if you have lighting, and I don't even know how to begin to Google that, but I'm like, if there's a permanent human settlement on the moon, and let's say it becomes eclipsed, Ralph, let's say there's light being emitted from that, would you be able to start seeing little lights on the moon's surface at night when it's partially like a new moon? I don't know.
Gosh, you know what, Ben? Maybe, huh?
That would be a strange future. That would something.
That would be something.
Yeah, and of course they could always put little roofs over it so that you couldn't see the lights from here on Earth. But I don't know.
Yeah,
it's a certain something to consider. But still, they're just talking about putting roads on it, and that's even a high technology proposition. Something that's so basic here on Earth. So very, very cool.
Yeah,
and
that's
fun
story.
Help. Yeah, fun story. So story number 1, story number 2. Let's go ahead and skip on down to that one.
Yes, story number 2. You and I, Ben, have some history with this story, and I'll explain in a moment. Headline: These solar windows are an invisible alternative to solar panels. Got this from CNET. Again, we have the links and everything in the show notes. Come out to computeramerica.com and get the show notes. And I want to make a commentary at first. So this is not a new idea, but the latest step in a global research and delivery effort to offer windows that can act as solar panels. Not in lieu of, but in combination, I would argue. About a year ago, Ben, we talked about a company in Australia called Clearview. That's Clearvue. They've been working on this for quite a while, and I have a link in the show notes. You can check this out and refresh on who these guys are. They're Australians and genius guys. This news story has to do with an announcement from MIT, Massachusetts Institute of Technology. And so I wanted to put a qualifier in here because the way it was positioned, and it's not a criticism of MIT, but it made it sound like they were the first people to come up with this idea, and that's simply not the case. Mm-hmm. But here's the story. For decades, generating solar power has meant installing big solar panels on your roof of an office building, your house, whatever it may be. But what if you could generate electricity by harnessing light that passes through your windows? That's the promise of solar windows, a cutting-edge technology that could change the way we build sustainable infrastructure and generate power in the future. Okay, so there's the setup. Now, here's the news. The technology was created by researchers at MIT who spun off the development out into a company they call Ubiquitous Energy and a solar window product called UE Power. And we've got links, additional things in a video and so on for this. And Ubiquitous Energy says its completely see-through solar window panels are the world's first aesthetically acceptable. Okay, that's the key word, perhaps. They may have realized, of course, other people in the world are working on solar windows. Mm-hmm. Maybe they contend they've come up not with the first solar windows ever on the planet, but the first aesthetically acceptable. Interesting. So that may be the qualifier. When I saw that in their press announcement, I thought, okay, that's how they're kind of getting around the literal fact that they are not, in fact, the first people to come up with the solar window. Sorry to drill on this point, but I just want everyone to be, let's be honest. So the world's first aesthetically acceptable electricity generating alternative to traditional windows. Now, this is interesting. Traditional solar panels are designed to capture every single photon of sunlight that lands on their surface. That's the goal. Of course, we know that's 25 to 30% of success for most solar windows. But Ubiquitous Energy Power lets visible photons pass through the glass while capturing invisible light, specifically ultraviolet and infrared waves. That invisible light is then converted into electricity, which is directed through a tiny wire that comes out of the window and connects to the building's wiring, just like a standard solar system. So, folks, that's the underpinning idea behind solar windows. Pretty cool stuff. And the result is a piece of glass that looks like a regular window, but one that can generate power. Pretty cool.
Yeah.
And here's a little bit of reality check for a second here. The company has rolled out Ubiquitous Energy Power in 12 pilot installations, including at Michigan State University and its own headquarters in Redwood, California. More reality check, folks. The panels right now are small, roughly 14 by 20 inches, but the company is working on plans to build its own production facility to manufacture floor-to-ceiling solar glass panels for commercial applications. And I'm saying, well, why not homes too? Sliding doors, everything, right? And another reality check, it's estimated that these commercial panels would cost 30 to 40% more than traditional passive glass. But of course, friends, if they generate enough energy to offset that initial investment over time, right, then it still could be a positive thing, especially not only for new construction, but maybe for retrofit as well, retrofitting. And finally here, though you can't buy Ubiquitous Energy solar windows for your house just yet, the company has partnered with glass manufacturer, get this, Andersen Windows, a giant historic company in the field to sell the panels for residential homes someday. There's no date given on this, no target date. But again, this is really more in the trends category, Ben, for us, because we know the Australians are working on this. There are other people working on solar windows. And here now MIT has jumped into the fray, and they've created a spin-off company called Ubiquitous Energy. It's a trend to watch, folks, because it's going to keep coming and getting better and better.
So let me blend a few different pieces of technology and, maybe come up with something that, and I'm sure, again, much smarter people than myself, but if you're watching the video portion, you're going to enjoy this.
Yeah.
For everyone else, we'll try to describe it. This happened at CES actually about 7 years ago, so this is back in like 2016. This was a demonstration that BenQ actually gave. They kind of took their computer monitor technology, and you can see a presenter there kind of showing off what it looks like, where they're showing a window going translucent to opaque, and by opaque, I mean like completely like black, like you can barely see through it. Ralph, imagine windows like you're talking about that generate solar electricity, and instead of being completely see-through and you can see out them, imagine if they had this kind of technology that you could make it more able to capture those photons, and if someone wanted to look out, hey, flip a switch and you can see out just like any other window.
I love it. I really do. And
something
folks,
like
if you're looking at my head and you see me looking up, it's because I have a big monitor up ahead where I see Ben and I see the video. So I'm not looking up to the Almighty God here, but I guess maybe I am.
Yeah, there you go.
But no, that's genius. That is absolute flat out genius.
Even something like that, and then Ralph, the humble motion sensor. I don't know if you've been to supermarkets lately, where you walk down like the frozen aisle section and like all the lights will turn on and off. Imagine if the room's not occupied. This technology turns on, you walk in the room, the whole thing lights up, and the windows open up. Something like that.
Yeah, motion detection. I mean, you can combine, your point's really well made, and that's what a lot of people do. These entrepreneurs go, oh, I could take this from MIT, and I could take this from these guys, and I could take that from over here, and put it together, and what do you got? Bibbidi-bobbidi-boo. I mean, just unbelievably great stuff.
Of course, what I'm talking about is mixing like 12 twinkle-in-the-eye technologies into something that is, just going to be revolutionary. And there's so many hurdles between here and then, but between Michigan State University, MIT, and of course great companies like Clearview, like you mentioned, there's lots of very, very cool people working on this kind of stuff. So I have hope that in the future, every window you see is not just going to be a window; it's going to be something generating electricity, and that's going to be great. So perfect.
And the key word you just used is hope. And that's what we do every Friday, folks. Ben and I are going to leave you with hope for the future, not despair.
They're actually no, really, Ralph. You're serious. It's like there's so much to be, looking forward to, and I'm glad that we do our segments because sometimes that gets lost on people, and they're like, what is XYZ going to do? And it's like, man, there's so many cool things out there that I'm looking forward to. It's so much. So story number 2 really highlights that. Story number 3, the image alone looks like Star Trek, but let's talk again a little high-minded here with a revolutionary new engine.
This is definitely a trend to watch, and you're going to find out the flavor of this. And the application they're going to talk about is for military purposes. But friends, military is one thing. For some reason, it struck me odd that the article didn't stress that this technology could roll over for peaceful purposes as well. But let me get into the topic. So Raytheon is building a revolutionary new detonation engine for the Defense Advanced Research Projects Agency. We'll just call them DARPA. All right. Good old DARPA. Got this article from wonderfulengineering.com, a terrific website. And again, come out to computeramerica.com, get the show notes. We have the links, everything, pictures for you in the whole 9 yards. So for details on what a rotating detonation engine is, I have a link to a really good classic Wikipedia article. But here we go. Aerospace and defense firm Raytheon is leading the development of the innovative air-breathing rotating detonation engine to support DARPA's Gambit program. And I have a link to the Gambit program. That's very interesting in its own
I haven't
right.
heard of that, yeah.
Yeah, and rotating detonation engine. Maybe you've heard of these, Ben, but that was a new one for me. I said,
new one for me.
What is that? Okay, because it does not require traditional moving parts. Let that sink in. Because it does not require traditional moving parts, this novel propulsion technology has the potential to completely transform the aerospace sector and open the door to lighter, more affordable missiles with longer ranges. Well, that's the military part of it. But my brain went right to, well, wait a minute, what about peaceful commercial,
cars,
purposes? Why in the heck can't this be something for aircraft in the commercial segment? Anyway, here's the problem. Traditional gas turbines, prevalent in modern air travel and weapon systems, pose numerous challenges. And a bit of this is sort of obvious. They are intricate, heavy, expensive to manufacture and maintain due to their multitude, of moving components, and necessitate specialized materials to withstand high operating temperatures. They also require specialized technicians. Don't forget the human part of this. When integrated into expendable weapons like cruise missiles, one and done, these drawbacks limit the payload capacity and escalate costs significantly. To address these issues, the rotating detonation engine has emerged as a viable alternative. And we have some diagrams here. I have a link to where I got these images and so forth, trying to explain what a rotating detonation engine is all about. This engine replaces the complexities of gas turbines with a distinctive combustion process involving a combustible mixture of fuel, so there's still fuel, and air within a gap between coaxial cylinders. What? Look, I don't pretend to understand this fully, but it's fascinating. And this part, I love this. You're going to love this. The combustion forms a supersonic wave that circulates within the gap between the two, the cylinders, right? Mm-hmm. Generating heat and pressure as it moves toward the nozzle, resulting in thrust production. Whoa, supersonic wave. The advantages of the rotating detonation engine are evident, featuring a simplistic design, cost effectiveness in mass production, reduced reliance on exotic materials, ding, 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 that's very important, and a lightweight and compact form. What's not to like about this? Additionally, rotating detonation engines can be configured with ramjets, gas turbines, and rockets, offering versatile applications across various domains. And again, I stress, why not for peaceful commercial purposes? DARPA has contracted Raytheon to advance the Gambit program rotating detonation engine from the testing phase to a functional demonstrator. So, friends, this is a real good example of a trend. We're talking about, very early on with the research, right? They haven't even made a functioning demonstrator yet. That's why you're getting this early. We're bringing this to you real early. This initiative is part of a phased approach focusing on preliminary design, fabrication, and testing to refine the engine for integration into future military weapon systems, particularly next-generation standoff missiles. The ultimate objective is to develop a rotating detonation engine that can be seamlessly incorporated into upcoming prototype weapon systems. Wow. Okay, this is twinkle in the eye. And again, I want to say again, this could be for peaceful purposes too, friends.
I've seen so many cool things that you've kind of brought here, and like the image alone, that weird purple, kind of emission that this thing is putting off is just, so cool and futuristic. And by the way, I've actually seen this technology once before, but I think I have an image of it here. If you're seeing, yes, this car right here probably uses something very similar.
Yes.
For everyone who can't see it, the Jetsons, I'm sure, use something very similar. And I don't know what this thing sounds like, but I'm betting it's going to sound like the Jetsons car as well.
Yeah, you know what? That's a good point. It probably has I'm going to guess if it's supersonic wave, through two cylinders, it's probably a whoosh sound.
Yeah.
It's probably not your typical jet sound, I wouldn't think.
Yeah, it really makes so much sense that, something like this would, because inside, I guess, every cruise missile and whatever, you're essentially building a little plane or like a little jet engine, and not essentially, you are building a little jet engine inside every one of these expendable, pieces of equipment. And this is something that's just, I guess, once you get the design down, you're just, injecting fuel, igniting it, and out comes, the supersonic wave, the propulsion. So,
well, yeah. Imagine, Ben, in the future, maybe with, again, I keep thinking about commercial, peaceful uses. In the future, green hydrogen is the fuel source. The combination of that with this could be just a fabulous, utter transformation of the aviation industry. Right now, there's so much work, as you know, in the aviation industry to look at green hydrogen for retrofitting existing jet engines. But what if you could just wholesale swap out everything for these rotating detonation engines? Wow.
And I mean, really, like, instead of even, and here's me putting on, maybe possibly in the future, Ralph, like, if they're so simple and they do provide that good use of thrust, imagine if, let's say, on maybe like spacecraft, you would of course have to build a much bigger one, and instead of like the big fuel tanks that you see, maybe something like this, it could be possible. Or what if you mounted these things onto planes, and to get that initial takeoff, you use these to kind of supplement the amount of thrust that you need.
Oh, interesting idea.
It'd be much simpler and much more efficient.
Wow.
Little things like that, could make all the difference in the future. So, research has to happen first. So I'm looking forward to see, kind of if they can, if they can get this working. Because again, Ralph, thrust with no moving parts is just that is futuristic in itself. So
isn't that great?
Cool.
Yeah.
Yep.
Yeah.
Story number 3. I did not give Ralph permission to use my likeness in story number 4, but we're going to go ahead and jump into it. So even with that, Ralph, how'd you get this? I want to know.
I tell you what, if you can transform into this little mouse, then that's quite a trick. Anyway, folks, if you are watching us, you know what we're talking about. If you don't, come out to computeramerica.com and get the show notes of story number 4. How could you resist this headline? Scientists develop drug that prevents weight gain in junk food eating mice. What?
That seems like the more possible outcome than me stop eating junk food. So I'm glad they're working on that.
I got this from sciencealert.com. If you're listening to us as a podcast only, the image is a little mouse juxtaposed with a tower of sugary donuts. Okay. Yes. So that's the junk food reference. This is a very kind of complex story, but I could not resist the idea of someday there might be a drug we can take that allow us to eat all the junk we want and not gain weight and hurt our livers and so on and so forth, which is maybe not a great idea, but still pretty darn interesting. So here we go. Mice fed a high sugar, high fat diet for most of their lives. Remember, mice don't have very long lives. Managed to escape weight gain and protect their livers when they were treated with an experimental new drug. And again, friends, this is a little complex, so geek out a warning up front here. The small molecule drug was developed by a team led by the University of Texas Health Science Center in San Antonio. Known by its chemical acronym CPACC, and I'll just call it CPAC, okay? It works by limiting the entry of magnesium into the mitochondria, limiting the entry of magnesium into the mitochondria. And you'll see that magnesium plays a role in the series of events and research that leads to their conclusion. So bear with it. So mitochondria, the parts of the cell in charge of generating energy and burning calories. Side note, wait a minute, what are mitochondria? Well, mitochondria is a plural of microchondrion. A mitochondrion is an organelle found in the cells of most animals, plants, and fungi. Mitochondria have a double membrane structure that use aerobic respiration to generate adenosine triphosphate. Oh my gosh. Anyway, it's just more mouth gobbledygook, which is used throughout the cell as a source of chemical energy. And again, the show notes have a link. You can learn more about that. Side note, too, mitochondrial abnormalities have been implicated in a range of diseases, including obesity, diabetes, and cardiovascular disease. All right, back to the story here. Along with calcium, potassium, and sodium, magnesium is one of the 4 major positively charged ions that contribute to cellular functions in the body in multiple ways. I warned you this is going to be geeky, folks, and I also confess I don't fully understand it. In fact, magnesium plays many important roles in maintaining health, such as regulating blood sugar and blood pressure and helping construct strong bones. But here's the problem. Too much magnesium slows energy production in the mitochondria. University of Texas researchers discovered the new drug while studying the effect of deleting a specific gene called MRS2. Time out. So what's going on here is they were doing research about the effect of deleting a specific gene called MRS2. In the course of that research, they discovered this drug. So it wasn't, the drug itself wasn't initially the end goal. So that you need to keep that in mind. So again, the University of Texas researchers discovered the new drug while studying the effect of deleting a specific gene called MRS2, which encodes a magnesium transporter protein called MRS2. There you go. This protein acts as a channel to transport magnesium across the mitochondrial membrane. I know, I'm sure everyone's getting cross-eyed right now and leaning over here like this. This
is taking me back to my high school chemistry class that I totally did not pay attention to. Yes.
There you go. This is, like I warned everybody, this is geeky, but again, the implications are so important that I did want to share this. So they investigated the effects of a long-term high-fat, high-sugar, and high-calorie Western-style diet, that's depressing, on normal mice compared to mice whose MRS2 gene was deleted. MRS2 deletion led to leaner, healthier mice with improved sugar and fat metabolism in their mitochondria, despite consuming the Western diet starting at 14 weeks of age for up to a year, which is a long time in a mouse's life. In further experiments with administration of the newly discovered drug, CPAC, the University of Texas Health Science Center team reported the same effects as deletion of the MRS2 gene. Okay, you get the picture here? They found that if you delete this MRS2 gene, you get all these benefits of being able to eat junk food and not have any bad things. But they found out that CPAC, this new drug they discovered, does the same thing as if you deleted that MRS2 gene. All right. Took me a while to kind of, I think, get it right and figure out what they're saying. The drug that they discovered in a way, not intentionally, it kind of was a side benefit of working with this MRS2 gene business. So the drug worked by inhibiting the magnesium channels that the gene encodes for. Again, it resulted in lean, healthy mice by reducing the amount of magnesium transported into the mitochondria. So the mice were eating donuts, the mice were eating Cheetos, the mice were having a great time and didn't have any bad, negative effects. So, will this come to humans? I don't know.
The last time I saw a mouse eating the Western diet was in that viral video, Ralph. If you remember, it was like a New York rat carrying off a giant slice of pizza, like up the stairs. And
yes.
The rat was huge, and of course the pizza was huge, and I don't know, I'm sure the two kind of played into each other. So before we get into honorable mentions, and that's really cool that they're able to, of course they're saying that they're making them healthier even though they're eating not so well. So this probably isn't a true correction of complete nutrition, but it's at least stopping some of the bad things that we've kind of done to ourselves. So, every little bit counts. And by the way, Ralph, for everyone out there who has a little bit of time to kill at work or, just wants to do something fun, and I know AI images aren't everyone's thing, and, they get a little tiresome. I love this image at the head of this page with this mouse staring at the donuts. So I decided to actually use Bing, and I know Microsoft Bing. Who knew? People actually use that thing. The image creator, Ralph. If you haven't played with it,
I played with it. It's fun.
The DALL-E 3 image creator from Microsoft Bing. I decided to make my own, and that's probably going to be the thumbnail of today's show.
I love it. I love it. Can you send me that image?
Sure. Yeah. And I made a few.
Oh my gosh. Yeah. These are great.
Yeah. They're.
Oh, I love it.
They're all really cool. And one of these.
That one's really good.
Yeah.
So, it's a pyramid of donuts, folks. If you're listening to the podcast with a little mouse looking up.
they're.
Oh yeah, Ben.
Yeah.
Send me those images. I love it.
I absolutely will. And AI image generation aside, this whole article about potentially getting people healthier, and of course a change in lifestyle is always recommended, and this, that, and coulda, shoulda, woulda, but getting them over that initial hurdle, getting them healthier, hey, that's probably more important than anything else. So there you go.
Pretty
not shaming anyone for, Ralph, there's really not such thing as like an easy way out. It's just, how do you get them healthier? That's the bottom line. And I'm glad that the research is pointing a way to do that. So, ladies and gentlemen, that's story number 4, if you're keeping track at home. And if you may notice in the, and Ralph, I don't know if we're going to cut these out and do these next week, or if you have whole new stories next week, but at the bottom you have honorable mentions.
Yeah. Next time. And next week, I'll do just a posting, since Ben and I are both going to be out of pocket. So we'll just do a little posting of some stories. But what we like to do now, this is a new thing for Ben and me, is honorable mentions, because there's so much great news. We can't cover it all, right? So a couple of headlines. I'm just going to give you the headlines here. NASA is visiting an asteroid valued at more than the entire world's economy, but it's not why they're going there. Well, that's a pretty cool one. Business Insider's the source. It's a cool story. Here's another one. What if the humble house brick could store power? Researchers reveal new material and shed light on exciting world of structural capacitors. That's from Tech Radar. You can get the link and everything in the show notes here. Here's another one. This off-roading solar-powered vehicle just sped across the Sahara. Designed by college students, the Stella Terra zipped through Morocco and portions of the desert as fast as 90 miles per hour. Key thing here, solar-powered vehicle.
It even looks a little bit better than the Tesla truck. So very cool.
Isn't it? Oh, yeah, the Tesla truck. Yeah. Don't get me started there. Here's another headline from CNN. 8 billion-year-old radio signal reaches Earth. How weird is that? 8
How
billion.
old is the universe? No, the universe is like 13 billion, isn't it? Yeah.
Something. Yeah. I mean, it just, that stuff, just everything from James Webb and all that just melts my mind. Here's another one I thought was interesting. Intel launches industry's first AI PC acceleration program. New program provides software ecosystem with engineering tools and resources to enable artificial intelligence on more than 100 million PCs through 2025. Wow, there's a lot of cool stuff behind this story. So please, come out to the show notes, click the link, get out to the newsroom at Intel and check that story out. It's fascinating stuff. So that's our honorable mentions for this week. And as Ben mentioned, early part of next week, I'll post some other stories we won't be able to do on air with you folks, but at least they'll be there and you can check them out and have fun with it.
Absolutely. And of course, check out social media. We'll have a link to all of that and more. And we'll keep up to date there. Again, the shows may be a little wonky here in the near future, but ladies and gentlemen, we're going to do the best we can to kind of bring you all these great stories because, this may be the first bit of good news, I've kind of seen in the news in quite some time. And I always enjoy these segments with Ralph. So, ladies and gentlemen, if you want more, computeramerica.com. We have a whole section dedicated to Ralph and his work. And of course, we include a link to his website where he does that and more. And Ralph, thank you so much for coming on. This was a lot of fun, and I missed this last week. So, ladies and gentlemen, until next time, have a great day. Thank you so much. We'll catch you next time. Bye-bye, everyone.